This video is on mathematical models, or the start of mathematical models, and we're going to look at linear and piecewise models. A linear model can be represented by a straight line graph. To create a linear model, you need either the coordinates of 2 points or the gradient and 1 point, and then you can find the equation. So really quickly, one example of this. Find a linear model that goes through the points 1, 3 and 5, 11. Give your answer in the form y equals mx plus c. We've been given 2 points, which means the first thing we need to do is find the gradient. So we just use the gradient formula y2 minus y1 over x2 minus x1. And remember, with your points, it doesn't matter which way around you use them, as long as the 2's correspond to the same point and the 1's do. So you do 11 minus 3 divided by 5 minus 1. So the y coordinates minus from each other and the x coordinates minus from each other. And this will give us 8 over 4, which equals 2. So our gradient is 2. From there, we want to create the equation of a line. I always like to use this form, as you just put your values in and then rearrange into the form that you would like it to be. And with the y1 and x1, you can sub in either point. I generally use the values that look like they'll be easier. So I'm going to use 1 and 3. Y minus 3 equals m, which we found out before was 2, the gradient, and then x minus 1. And then from here, it's just rearranging to y equals mx plus c. I'll multiply out the brackets here first, and then add the 3, and you get y equals 2x plus 1. I'll now just sub in the other point, and then you can see you get the same answer. Obviously, you don't have to do both, you just pick one. y minus 11 equals 2 multiplied by x minus 5. That would be y minus 11 equals 2x minus 10. Add 11 to the other side, and you get y equals 2x plus 1. So you can see you get the same answer no matter which point you sub in. Next, piecewise linear models. Sometimes a different straight line model applies in different parts of the domain, producing a piecewise linear model. So it means you have one straight line graph, and then it gets to a point, and then a different straight line graph joins on in a way. And so if we're going to graph that, you would have, say, a line that went to there, and then it maybe went that way. So you'd have an equation for the first half of the line, and then you'd have an equation for the second half. That's a piecewise function. This example, a mobile phone contract has a monthly charge of $50 plus $1 for every 10 minutes of call time for the first 100 minutes, then $1 for every 20 minutes of call time thereafter. We have a monthly charge of $50, so that is there no matter what. And then $1 for every 10 minutes of call time for the first 100 minutes, then $1 for every 20 minutes of call time after that. So if we look at part A for forming the piecewise model, and it says for the cost in terms of the call time. So it will be C equals, and then our equation will have T in it. So if we think about, first of all, when T equals 0, what would our cost be? So our cost would just be $50, because at the start of a call, just as time's passed, you're always charged that monthly charge of $50, whether you make a call or not, because it's a contract. Now, our second situation, we know this goes up to 100 minutes. Now we know the cost of that would be $60. Now the reason we know that is because we get $50 to start with for the contract. Then we've got $1 for every 10 minutes after, which would be 1 times 10, because you've got this 10 minutes in 100 minutes, which equals 60. So that's 50 for the initial cost for the contract. Then you have 10 minutes in 100 minutes. It's $1 for each of those 10 minutes. Now we can, with the information, we can create an equation for the first line of this model. Because we have two lots of coordinates, 0, 50 and 160. So from here we can find our gradient and find the equation. So our gradient will have 60 minus 50, our y values, minus from each other, divided by 100 minus 0, which gives us a gradient of 10 over 100, which is 0.1, or 1/10, however you would like to write it. From there, then we can create our equation. Once again, I'm going to use the form c minus c1 equals a gradient, and then it'll be t minus t1, just substituting the y's for c's and t's. With c minus c1, pick a point, I'll use a 0.50, equals the gradient, which is 0.1 multiplied by t minus 0. And then rearranging, we'll get c equals 0.1t plus 50. So that's the equation for the first part of this problem. Now for the second equation, we've got $1 for every 20 minutes. So now the 2 points we can use on this, we know that it changes over at when t equals 100, c equals 60. So we know that's the start of the second line. So we can use that as our starting point. Now we just need another point. I'm going to go with when t equals 200 because that is easy to work out. Now to work out the cost of this, I'll tell you the answer is 65, but now I'll do the reasoning behind it. So from 0 to 100 minutes, we know that cost is 60 because we worked that out before. Now from 100 to 200, we know this cost is $1 for every 20 minutes. Now there are 5 20s in 100 because we're going from 100 to 200. So it'll be 5 times 1. So that part will cost $5 because it's $1 for every 20 minutes. And then within 100 minutes, we are going to get 5 20s. Then from here, we can work out the equation of this line. So our m, let's go 65 minus 60 over 200 minus 100, which gives us 5 over 100, so 0.05. Obviously, you can leave your answer as a fraction if you wish as well. Then work out our equation. So c minus, pick one, I'm going to use the first one, c minus 60 equals 0.05 multiplied by t minus 100. And then we just rearrange this. So we end up with c minus 60 equals 0.05t minus 5. And so c equals 0.05t plus 55. And then when we write something as a piecewise function, we have c equals. We use these brackets that look like that. We put the first equation on the top line, which was 0.1t plus 50. We put the second equation underneath it, so 0.05t plus 55. And then we need to write the domains. So what values did it go between? So for the first equation, it goes from when t equals 0 all the way up to when t equals 100. And for the second one, it goes from when t is greater than 100 and up onto infinity. So with that one, you could write it that way, or you could write it as t is greater than 100. Because there is no ending time on that, because you can talk for however long you want on the phone. So remember, that's what a piecewise function looks like. Part B. Find the total monthly cost in a month when the call time was 350 minutes. So for 350 minutes, we just need to look at which two of these equations it falls under, which is the second one, because our t is greater than 100. So c would equal 0.05 multiplied by 350 plus 55. And that means the cost would be $72.50. And that's the end of this video.